Hello everyone, welcome back to the channel PHYSICSSIRJEE. Today I'm going to present to you a tough challenge on relative motion concept. This question has appeared in one of the past school Olympiads. So the question is about tracking the smoke trail coming out of a train which is moving in the presence of a wind. Okay, so this is the formal wording of the question. The figure at an instant shows the aerial view, that is a top view of a straight stretch of railroad. Two steam locomotives, that is nothing but trains, A and B, move in opposite directions with constant speeds of 50.4 kmph and 72 kmph respectively. At this particular instant of the picture that is shown, AC corresponds to the smoke trail from train A and BC corresponds to the smoke trail from train B. And at this instant when the picture was taken, the length of AC is equal to BC. Determine the wind speed assuming it to be horizontal. Dismiss or neglect the distance between the rails A and B. So even though there are two parallel tracks that he has drawn, imagine that gap between them is negligible. So you can safely assume that it is one A and B moving on the same straight line. Neglect the inertia of motion of the smoke, that is assume smoke particles have negligible mass, and assume once they are emitted, it automatically gets pulled along by the wind. Okay, so please do understand that this is a top view. So what we are looking at it as a horizontal plane. So the distance at that particular instant of the two train is given as 1360 meters, and this height of the triangle that is formed by the smoke trails which intersect at C is given as 160 meters. So with this information, you're supposed to calculate what is the speed of the horizontal wind in this particular situation. Okay, so try to pause the video at this particular point of time and go ahead with the trial of the question and then follow the solution that I am going to present. Okay, so here's the solution that I would like to present. So this is a concept that is very, very important, right? I have divided the concept into three parts, case 1, case 2, and a case 3. Okay, so we are now assuming certain cases that's not given in the problem. So then we'll move on to the actual problem. So you could see in case 1, I'm assuming that wind is absent, right? Wind is absent, and there is a train. All of these are pictures drawn from the top. You are watching from the top. Okay, so on the top view, when the train A is moving towards right, let's assume train A is moving towards right with a VT bar velocity, there is no wind at all, then you could see the smoke trail actually is along the same line of motion but in the backward direction of that. So can I argue that the direction vector of the smoke trail as this train moves would be in the minus VT bar direction? I would like to show you the actual thumbnail where we started our question with, and in the real picture also you could see in the absence of the smoke trail, you could see the trail of that smoke is in the backward direction. You could see this is the front end of the train, which is the engine, and engine is moving in the forward direction, whereas the trail in the absence of wind will go backwards. So that's the importance of this picture in the thumbnail, which is what I depicted in case 1 here. Now let's move to case 2, in which let's say this is a train stopping at a station, but still the smoke is, let's suppose, coming out and only wind is there. So case 2 is train at rest with airflow. Then it's obvious that that smoke will go in the direction of wind. So here in the case 1, if wind is not there, the smoke will go in the minus VT bar direction. And in this case too, if VT is 0 but VW is there, then the smoke trail you could see is represented in the direction of VW. So case 3 is a simple superposition of the two velocity vectors of case 1 and case 2. Just imagine this train A is moving towards right. So this arrow actually is the direction of motion, and wind is in this direction, and I'm assuming minus VT bar is in the backward direction. So if only minus VT bar is there, this would have been the direction of the trail. Whereas if only VW is there, this is the direction of the trail, as you could see in these two vector diagrams. Therefore, I can argue that with the presence of both, the trail will be the resultant of the directions of these two given by the strength of these velocity vectors. So you could see that the trail in this case in the top view will look from this way. So from this particular concept page, take to the next page the idea that the trail for any train points in the direction of vector subtraction of v wind minus v trail. Okay, so that's the idea. We'll borrow into the next page. So I took the picture of the actual diagram in the question. So train A, if the trail is this way AC, and train B, if the trail is at BC like this, that means when they are crossed through the point, remember they are moving in opposite directions. So A should be moving towards left in this picture and B would be moving towards right in this picture. Just imagine they have crossed at one particular point called P in a past of this photograph. So this photograph is, let's say, at one instant, the crossing point would have happened in the past of this photograph. So imagine that point is P. So if the first puff of smoke comes from A here and first puff of smoke comes from B also at this place, then those two puffs will always travel together in the direction of wind, and by the time the present photograph is taken, those two puffs would meet at C, which is what I depicted in this particular diagram. So I borrowed this point P, which was the meeting point in the past, and you could see after time t, the train A would have traveled PA in the leftward direction, you could see VA into T, and train B would have traveled VB into T, right, in the forward direction, as you could see, rightward direction, I should say. And the puff of smoke that came from each one of them in the past would have traveled along the wind and met at this point C. This is your point C. Okay, so this is the logic behind drawing this diagram. And then you could say that smoke trail of train A is vector subtraction of the VW and VA. So the smoke trail over time t, this AC, I'm depicting it in this direction. You could see that's a subtraction of VW and VA and multiplied by t, because these are distances triangle and not the velocity triangle. So even this would be multiplied by t here. Same logic, you could see blue vector minus the yellow vector would give the smoke trail of the train B. Unfortunately, in this picture, these two are said to be equal to each other by magnitude. You could see AC is equal to BC, and from here, right? So let me mark C so that we'll be able to locate that. So this is your point C. So which obviously means that the distance traveled PA plus distance traveled PB is the 1360 in this triangle. So I've just written that equation here. We just convert VA, which were given in kmph, into meter per second, then and substitute the values of V and VB here. You will end up getting, upon solving, immediately the value of T should be equal to 40 seconds. Okay, so once t is 40 seconds, you also know what is this gap, right? You carefully observe that gap in the triangle. That would be simply the subtraction of entire VA, this should be VB into T minus the value of VA into T. That would be the value of this particular expression. So because you could see that this entire thing would be 1360. So the half of that 1360 would be VA. So it would be VAT plus VBT divided by 2, right? So this half would be this number divided by 2, and then you have to subtract this part. So this would be simple subtraction of these two. So that particular part, let's call this M as the midpoint. The value of PM would be simply equal to VBT minus VAT, and that would be equal to the subtraction, which is 60, right? Because it would be 20t minus 14t, 60, and the value of 60 is with 40 seconds given as 240 meters. So since that is 240 meters, the value of CM was already given. Can you see this? This 160 meters was already given. Okay, so that would give you, this is 160 meters. So you have a right angle triangle here. Can you see there is a right angle triangle with this as 240 and this as 160, right? I think I made a small error here. Okay, so this should be divided by 2, I think. So this should be divided by 2. Okay, and therefore you end up having this one to be 120 degrees, 120 meters, and right. Okay, so if this is 160, this should be 120 in the picture. So the third side of the triangle, VW into T, would be equal to 120 whole square plus 160 whole square under root, gives you 200 meters. Okay, so what's the value of VW therefore? With T already known as 40 seconds, we would end up getting that VW as 5 meter per second, which is nothing but 18 kmph. Okay, right. So that's the idea. One of the doubts that you might end up getting is why should the smoke actually start at the same point for both of them? So could it happen that this trail started at a different instant as compared to this trail? The logic is very simple. If you carefully observe that any motion which is perpendicular to the line of motion, any motion of the smoke trail perpendicular to AB is only due to the VW's component in that direction. So can I write this white line as VW perpendicular times of T? And this VW perpendicular is independent of how fast the trains are moving. Since this distance multiplied, this particular distance is due to VWT perpendicular into T, that should be same for both the trains. And that justifies why I took both the puffs which meet at C later on, or which actually travel together, right? It's not meeting at C. The puffs actually travel together to this particular point. Remember, these points are puffs which are developed or which are emitted at some other positions between P and A, right? So there are other trails also, that the things that have moved to these points on the AC. Okay, so that's the whole logic in this particular question. Okay, so I hope you like the journey of this particular problem. So in case you did that, please do like this video. And in case you are a regular visitor to this channel, I would request you to subscribe to my channel. I'd go through the playlist of the different concept videos that I have produced. And please do share the content of this with your fellow students and fellow lecturers, in case they would be interested to come, and they would motivate me to produce more such content. Okay, so thanks for your company. Right, see you in the next video.